Alright, we are live, hopefully. Let me organize my desktop. And we go here. And let's get this up. Oh, let me adjust the microphone. And actually we have a minute to spare. So let me get the microphone filter too. And put it in the table. So this is our second experimental lecture. Excuse me. I kind of forgot how to fix this filter. It should be a little bit farther so it doesn't get in the way. Good day everyone, my name is Ahmed Al-Aswad and this is my experimental lecture for basics of C#. Today we are going to take a look on variables, what are they and how to use them. So we will talk a bit about why we shouldn't marry one language. This advice might sound weird. If this is your first language, then don't worry about it. But hopefully you will remember my words later on. If this is not your first language, then you are not married to one language. Good for you. Then we will take a look on different type of languages, what are variables, how they work, and how can we use them. And after that we will take a look at casting and parsing. Marrying to one language. Imagine that you spent all your life in an isolated place. Maybe a cave or a big prison in an isolated island. It doesn't matter. The only thing you could eat in there is rice and soup. Nothing else. And the spoon was the only thing you used to eat. Never used your hand or other tools. One day, there was a loud noise. You and the group of people head to that direction just to see one of the walls fell down. And there is the horizon, an open world. Some of the people wanted to leave and some refused to try it. And these people tried to stop you from leaving. But you and a group of people left the place. After exploring in the city, you met something good. After exploring the city, you smelled something good coming from one of the places. And people were entering and leaving the place freely. That encouraged you and the party to enter and see what's going on. When you entered, a tall, well-dressed man welcomed you and showed you to the table and gave you a menu. He asked you what would you eat? Or what would you like to eat? You didn't recognize of the food. There's no rice and no soup. What the heck is going on? So you asked for recommendations. And that man picked few things for you and your friends. When the food came, you discovered it was such a chore to eat some of the food with a spoon only. You couldn't recognize the other tools on the table, so you kept trying eating it with a spoon. After running away from the pill and taking a tour in the town, and the sun started to set, you decided to return to the place and tell the people who stayed behind about the adventure. Do you think they will understand the weakness and the strength of the spoon like you did? Can they compare other food with rice and soup and comprehend or understand the texture and the taste? If you tell them you tried something really good and it's called pizza or steak or ribs or fruit salad, some might refuse to believe you and tell you even plain saltless rice tastes better than anything you tried outside. There is no way something else will taste better. Programming languages are tools for tools. I didn't mean it to insult anyone, but it's the truth. I'm a programmer after all, and I'm a tool too. We are here to solve problems and create solutions, not the opposite. We do that by picking and using a language. Each language has its value, strengths, and weaknesses. Some specialize, some more focused. Usually we love the first language that we learned the most, but you have to learn how to use other languages. The less you get stuck with one language, the easier to shift and use others. If you don't try them, how can you tell which language is stronger and more suitable for doing certain jobs? Not only that, you might learn a trick or two on how to do certain tasks in a language and reuse it in another. Learning new languages force you to try new things because of the lacking of certain functionalities and capabilities in these languages. Besides, the more languages you learn, the better you will become, and the better you will understand how the whole programming process work in general, how compilers work, and how the relationship between different languages and the operation system, and so on. It's alright to have a favorite language. For me, it was Visual Basic 6, then Java, then Visual Basic Net, and now C#. I was stubborn too, and stick with Visual Basic 6 for way too long. If I didn't marry that language, I would start at Java and Visual Basic Net much earlier, and that would bought me several years of experience. And don't take this matter personally too. Do you know how many people in real life came to me to argue that their favorite languages are just better than mine? Period. No discussion. And they came to me as well in live chat too, trying to troll me how sucks and calling me names and telling me that their favorite language is just better and what I'm using, thinking I'm married to it or whatever. Let me ask you a question. When you search for a job, do you think all jobs will require the language that you know? Actually, a lot of places use their own platform and languages that you probably never heard of before. Okay, maybe you have a job, or got a job in your beloved language. What happened if someday your boss came in and decided to change the platform, or the system, or some devices, and now you will use the language that you were laughing at, and laughing at their users, and call them all kinds of names from stupid to losers? What will you do? Quit your job? Calling your boss, who you are in good terms with, a loser? You need to learn how not to take these decisions personally, but professionally. You need to build your decisions based on the experience. If you know that Java is a hybrid language and run on Android and application run on Android and PC, and the application your boss want to build should work on PC and Android, then you could suggest to use Java because you already know this info. But if you like Visual Basic 6, for example, and you have no idea about Java and how Visual Basic 6 works, and because you love it, you suggested to the boss, hey, let's use Visual Basic 6 because I love it, you will become the laugh stock in the office. So let's talk about languages types, should we? So imperative language. Imperative or procedural or structural language is a language which the programmer required to enter a series of commands or lines, and they run in order from the top to the bottom, from the left to the right. These languages are specific in insane ways. They're so specified. Programmers in general use these types of languages, and because they are quite powerful, they grant the programmer a lot of control over his code. Most of these languages are OOP, We will discuss what is OOP when we will talk about the classes. The second type is declarative languages. They are the opposite of procedural or imperative ones. These languages are designed to take orders or tasks from the programmers and do what is requested without sharing with the programmer how the procedure is done. So the programmer tells the language what he or she, and tell the language the conditions, the parameters, and he will get the results if he ordered it right without syntax errors again. So these languages usually easier because these languages has the nature to hide complex procedures and take optimized route to get the answers for the programmers. Usually these languages deal with AI and databases relationships. The third common type are functional languages. Well, they used to be common. They are not that common that much, I guess. These languages made for math people and usually made by them. These languages don't have the normal type of functions and coding like you see in other types. And instead they are like tools to be used for math and physics purposes and researches. Of course, some of these languages show some power in other programming languages, mostly the OOP part. So they add some features from them. That's why there are two types of functional languages, pure and impure ones. Logical languages. These languages work in a different way. First, the first step, you need to set a list of rules or relationship. Second, add a bunch of data. Third, make a relationship between the data based on the rules. Last, you can use the program now. You can make queries that ask the computer about certain state, either in the form of yes or no, or ask the computer to list some valid queries of valid cases. These languages are usually used for AI. Most known languages with these types is Prolog and Prolog family. There are other types of languages, of course, like compilers family, interactive, data-oriented, machine languages, and others. You can learn more about them in your free time if you want. So, do you see how large this world is? Not yet? The only way to learn more about these languages is to try them out. Learn about their syntax and how they work. We will notice that how does the procedural language work when we dig deeper in C#. From now on, let's have a look on variable. So in programming, we deal with data a lot. Actually, we can argue that programming is all about data manipulation. But we will keep this discussion for another time. Data can be constant and have fixed value all the time, or not fixed, which is called a variable. Variables live in memory. So when we need to make a variable, we ask the operation system to reserve some memory location for us, for the new variable. Heads up, it will get a little bit messy here. It will get, I will get in a little bit in detail. So variables have two types, value types and reference types. So variables can be either be a value type or a reference type. What's the differences? Value types save its whole value in the memory location that we give it from the operation system. The reference type save only the address. This address points to the location of the data value and another location of the memory. We only save the address in the variable we make, but the operation system knows where is that variable real data by using this address. In this lecture, we will only deal with symbol value types, except the string. Strings are objects, and all objects are reference types. But no worries about it. Strings are a little bit special because it's an immutable struct. or an immutable, sorry, it's not a struct, I just said it's an object, silly me. So no worries about it. We will get in more details when we start talking about references, and that will happen when we start learning about classes first. We will have a deeper look on them another time. No worries about it. So let's focus on the symbol things. So the symbol types, symbol value types or variable types are byte, integer, long, float, double, decimal. And I believe there are more. Actually, they replace short and long in C#, and you can use int16, int32, int64. But I believe long still exists in C#. There were a lot of changes in C#. It has been there from 2002 till now. So there's a lot of things has been added to the language. Anyway, byte and integer and long, all of them save integer values. Like 1, 2, 3, 4. There's no decimal in, there's no real numbers. There's not 1.5, only 1. Float, double, and decimal save the real numbers like 1.7667. Each of these variables use different size in the memory. So you can see here, byte have save only 8 bits, short save only 16 bits, integer saves only 32 bits, and you can see the range of numbers in here. In addition to these things, we have boolean, which can save two values, two types of booleans only, true or false, which can be used for logical expressions, and character, char save only one character. And we will see and use a string to save a collection of letters or words. We will see that, but as I said, it's not a basic type, or it's not a value type. So here is a useful table that I stole from another PDF from the internet. Actually, I stole the info inside it and changed some of them because I didn't like how they are written. But at least I remade the table, you know. Anyway, as I said, value types, memories, anyhow, as I said, value types memorize its value in its memory section. Reference types save the address. They are stored in different data structure, which we won't discuss in here, stack and heap. And in the table, in the nullable section, it used to say value cannot be null. Actually, that's true in a normal way, but we can make variables type of nullable, and when we create them as nullable, they accept null. And this is really useful when you deal with data in the database, because in the database it's so usual to have null or zero. But we will take a look on that on the second part after the break. So whenever you create a variable, they usually have a value of 0. All these previous numbers you see, when you start a new one, they usually have on the initialized verse. Whenever you create a new one, they usually have 0. But if it's nullable, no, it will have null. Unlike the reference type, it usually starts with null. Null, if you don't know what's null and you never programmed before, never took math or discrete math before, means nothing. It's like phi in math. It's not 0, it's nothing. So we can have a break now. But as I see, because this is an experimental lecture, what I was going to say, I will pass that. We don't need to take 10 minutes break and do nothing. You can pass that. Nobody's watching now, and I will be lucky if people watch later on. So let's get in the practical part section, something. So let me get the live shot away from the first screen. So create a new project and put it in lecture 2, please, and we will see this. So here we will try to do the 3 steps to make variables and use them. The first step called declaration. What does declaration mean? Is we ask the operation system, please make space in memory to use for these variables. To do that, we need to enter the declaration inside the class or inside the function. Later on, we will learn about scope when we learn about functions. Scope, how to pronounce that, I'm not sure. Anyway, so to declare these guys, we need to use the name of the variable itself, the name of these guys. So example, static byte, and then we give it a name. For example, B1. And then we end the statement by the semicolon. What I was going to say. We will learn what does static mean later on as well when we learn about classes. And when we can use it and when we shouldn't use it. But this is not our subject today. So this is how you say to the operating system, hey, I want 8-bit in the memory please, because I want to save a variable called B1. So B1 is the way how we retrieve and set the value to this 8-bit in the memory. To use it or to assign value, we can say B1 equal to, oh yeah, byte. It won't accept integers immediately, right? No? Good. So now we assign, I believe, maybe the 0. No? Sometimes I myself need to learn more about basics. Sometimes it requires casting, I don't know why. What I was going to say. So now we set the value 5 inside the variable by using the equal sign. To use it, we could use the function to print the thing on the screen, just like we learned in the first lecture, which is asking the console to write line. And here, before we put hello world. Actually, we can put almost anything in here. So we can say B1, and then we enter read line, so we can see what's going on the screen. So if we run the program, there you go. You'll see there's 5 in here. I don't know if you can read it from there, and I can zoom in. I apologize for that. Oh, I'm sorry, I forgot to zoom in here too. I should zoom in enough. So there are other ways to assign values. In the same state of declaration, we can immediately actually give a value, like equal to 0 or equal to 3. And when we run it, we will see 3 in here. If we don't put a value, we should see 0. Because all the symbol types start with 0 if you didn't assign a value to them. Do you remember the green line from the first lecture? It tells you, hey, we didn't assign, or you didn't assign a value to here. So it tells you, and it will give you 0 by default. We could assign another variable and call it B2. Or we could assign another variable on the same statement by entering, what do you call it? Comma, and then give another name. What else? So we could use integer. An integer can go a little bit farther because byte can be why he's still unhappy. I'm not sure. Byte cannot leave more than 255. If you put it to 160, it will crash. Actually, it won't allow you even to compile. It'll tell you, hey, this is too large. We cannot give you 260. So here we can make this one 200 and this one 32,000. We could use what is called long or int 32. I believe they are the same. I should check before I came. I apologize for that. And L1 equal to, how large is this sucker? Let's say 2 million. If you put 2 millions in here, it won't be happy. No? Oh, this is already 32. So if we say 16, then it is not happy. So yeah, if you write stuff like this, static byte, you will notice there is a small one and a big one. Actually, this guy, there is no differences between this and this. This thing, the byte, the capital, is actually a system byte by calling the full name. This is just an aliases. In the old days, not even 2002, I don't know why did they do it like this. So some of the functions you can call it from here immediately, but there is no difference at all now between the two. But even the guys in the Microsoft tell you it's better to use the small one because all of them are here like string, and the small string. So I just wanted to tell you, don't get confused and say what the heck is going on. They are the same. This is just another name, an aliases. Actually, if you put the mouse in here, it says class system string, class system string. They are the same thing. This is just another aliases for this thing. So we got this out of the way. So let's get our integer, which is actually the same as long, if I'm not mistaken. If I'm mistaken, please let me know. You can search and see. Float. Usually, not usually, when you give a fixed value of float, you write it like this, F. You end it with F. If you don't end it with F, then it's represent double. The reason is the way how the position is saved in the memory for float is different than double. And we can give you an example to see how the heck they are differ. We can make an example hopefully for that. To be honest, I never ever used decimal, and I'm not sure if there's a letter at the end of the fixed value to distinguish between the two. Maybe D. Yeah, you see he's not happy with it at all. See? A double position floating, literally type double. Ah. So actually the red line told me I need to use M for that. See? Converted type, use an M suffix to create literal of this type. As I said, because these guys use a different formula to save the position dot point. And if you don't use these letters, it won't work. The formula of this guy won't work on this guy. This guy is very huge. It goes from 10 to the negative 28 to 10 to the power 28. Really huge, unbelievably huge. So I never ever in real life used it. The last one we didn't use is the char. And to write a fixed character, only a single character, you use single quote. To save whole word, we use double quotation for that. So this is how you declare variables and how to assign them. And we can make operations like I1 is equal to 10, and then we print I1. Or there are several operations, we can steal them from the notes. You have the addition operation, the subtraction operation, multiplication represented by the star from the numpad or shift 8. The division is, I believe it's called backward slash or backslash, which is shift question mark. And the mod, which is not the reminder, mod. You can search for it in Google. Mod is the percentage, which is shift 5F. So this is all the math operations we can deal with, and we can print it. Let's see, I is 1. So what else we can do? Oh yeah, I forgot about the boolean. Static boolean b1 is equal to true. Oh, we already have b. Let's make it capital B. We can either talk about logical operations or talk about casting. So maybe we should talk about the casting. So these variables, when you say I1, or let's make an I2. I2 is equal to 10. And this is equal to 20. We could use them anywhere to represent the values they have. Like I1 is equal to I2 multiplied by 10. So this is 10. So I2 will become 100. I was going to say plus 10. If you want to use another variable like the float and assign it into integer, things might go wrong. So F1. Why? Because this is a float. It has a value in here, 0.66. Integer cannot save this value. So there are two solutions, casting and parsing. Let's take a look on casting. To cast it means telling the language that to treat the value as another. So this is a float and this is 30.33. Let's make it 33 to make it easier as an example. So we tell the compiler or tell the language, hey, we don't care about this float value. Let's see it as an integer. Let's ignore this number, the 33. So to cast it, it's kind of weird, I know. Is to put the type you want to treat it, the value, before the value. It might be easier for you later on to put two parentheses around the value you want to treat it. So this will tell the compiler, hey, I want you to treat the value in here as this type, as an integer. So here, if we print float value, you can add a string with the float, but actually you don't add it. The compiler is too smart. He immediately converts this into a string. If This is the C# compiler stuff. Actually, we should say to string. This function will give you the result of a value of this float as a string. So I will keep it now, then later I'll remove it to just to explain to you. Integer value. Oops. So here we converted, casted f1 and treated it as an integer, and we gave it to I1, and we were going to print the f1 and the I1 and see the result. So the float value is 30.33, but the integer value, as we said, is 30. We could remove the toString because the compiler is trying to make our life easier, or the language, or whatever you call it, so we will get the same result. We don't need to tell it, hey, convert this into string so we can add it together. In older languages, you cannot even add the plus. With the string values, you need to use another operation. If I'm not mistaken, in Visual Basic, you need to use this, the AND. But every language has its own syntax, how it works. And that's why we're learning. We're learning how to use a C#. When there is a precision loss, you need to cast. So because float has a precision of 0.33, and we're going to convert it to integer, we're going to use the 33, we need to cast. If we don't, I didn't talk about comment, but when you put 2 backslashes in the sentence before the sentence, that means this become a comment, and comment doesn't compile. I'm sorry, I should talk about that before. I should talk about that in the first lecture, but I completely forgot. So if I say if1, treat this one as a float, I1, it will work. It will still work. So the float is 20 and the integer is 20 because we canceled this statement. We don't want to use it as a statement anymore. This is what a comment means. As you can see, the color is a little bit darkened because actually you don't need it in C#. Actually, if you click on this, the lamp thing, it tells you remove the unnecessary cast. You don't need to use it because it doesn't lose the precision. 20 in float it become 20. There is no precision loss, so you don't need to cast. Let's try double 1 is equal to 20.33 minus f1. And let's print the float and double and d1. You see the float value is 30. Oh, we turn it, sorry, but this is a very good example actually. You see the double is 20.33 and the float is 20. So 20.33 minus 20 is 0.33, and yet the result we get 3.2999998. Why? Because the precision of the float is less precise than the double, and therefore it's not exactly 3.3. If we got another double in here, d2 is equal to 30. Imagine if this imagine if I get wrong result now, because in Java there's a lot of weird mathematical crap in there. Oh yeah, we have the same crap in here. Sorry about that. So the precision in these values are not exact. They are not exact. Even if it's double with double, you don't get 3.33. And this give you some awareness that it's not exact. You shouldn't use the equality with them. Oh, we didn't learn about equality yet. So what else we can learn? So we can do operations, as you can see. We can use multiplication, we can use mod, we can cast between them. So we can, if I say this one is equal to this one, but if we say this one to this one, it's not happy. It loses some precision, so you need to cast it. But this one, no need to cast it, because this one is higher in precision than this one. There is no points lost. And the same from the float to integer. The other thing is casting. What is casting? Parsing. Parsing means to change the value from this to this. Not to treat it, but to completely create a new value from it. How to do that? We could actually use the string. For example, if I say 10.0, we can say f1 is equal to float parse, and this is how to use parsing. It's a function. It's 1. So here, if we print the float value, we should get 10. If we put here 5, 10.5. Similar, we can say integer is equal to int parse. Yeah, it's only convert from string to these values. So you cannot convert the other values to that. You can use casting. But to parse from string to these values, you need to use parse. To be honest, I never I never tried to parse float into integer by using a string. Let's take a look. Oh yeah, it failed. So if you try to do something stupid like changing from letters to this, it will fail. It will horribly fail. And that's what's called crash or exception. And when it happens, you should try to fix the problem, but we will learn about that later. This is just, we can take a quick look. So it says system format exception. Input string was not in the correct format. So the S1 is not an integer, in other words. So, what else? We could take a look on a trick. Character are saved in Unicode, which are 16-bit, and they're exactly the same as integers. So we can say A. Oh, I didn't stop the program. And we say here C1. Do I need to cast it? Maybe not. Because it's the same value exactly. We will get 64 or 65. No, 97, I believe. Because this is a, yep, 97. I didn't forget. Wow. I haven't used ASCII for a very long time. So this is the ASCII value because characters are saved in the same value as integers. Actually, you can interchange between the two. Or I can say I1 is equal to 64, I believe, or 65. I'm not sure. Let's make it 65. C1 is equal to, I believe in this case we need casting. Yeah, in this case we need casting. C1. And we will get capital A. If you didn't learn about ASCII, I'm sorry I didn't teach you about ASCII. You can search for it. ASCII. It is the American something from something. It's the first system that they made to save the English letters in the computer by using values. Alright, so let's deal with Boolean for a second. All conditions and all conditions use Booleans. And Booleans mean true or false. And it's used for these logical question stuff. Or logic puzzles. So if we can print Boolean. True. And we could use the Boolean operations or logical operations, and I can steal them from the notes I made before I went to the class. Yeah, I'm sorry if the class is a little bit horrible because I didn't practice a lot on what I'm going to say. I was like, let's make it a freebie and free lecture and stuff and see how it happened. So if you're familiar with the logical gates or what do you call the hardware gate things? The bitwise or the logic operations between true and false or 0 and 1. You have the OR and the and do you know I never ever tried in programming to use XOR? Funny, never tried that. So let's make it XOR. XOR mean it is true if there are different values. If it is the same value, it's false. So true XOR true is false. And yeah, it works like that. Silly me, never ever tried it. You can see that we have two or and two and this is actually someone, an Arabic guy, asking in a Facebook page once what's the difference between the two, and I like to show the differences between the two. The differences is that this one is sufficient when it gets the result. This one, the only one signal one, means make all the operations, check all the values. What does that mean? Here we can make it actually another what do you call it, another expression, a longer, a more complex expression, or even a function, like for example true and false. So this one will happen first, then it will this one will apply it. This one operand mean I don't care about this value if it is true or false. Apply this one and apply with them again and again. This one says if I meet true and I know that anything ORed with the true is a true, then that's enough. I'll return both of them true. I don't need to check what this value is. Same with this one. This one, the first time it finds false, if this one is false, it doesn't make a calculation to this one, no matter how big and complex it is, because it know already false, and anything you end it with false, it will return false. So this is the differences between the two operations. The last thing we can take a look on is what's called the nullable value. So the nullable value, we can make a nullable value like this: static int a1. So this means we don't know if this thing can be null or not. We cannot, can we? I didn't check, so let's check. Can I print a null? Will it crash? Nope, it didn't crash, but it didn't print anything. But we couldn't use it immediately, I believe. So for example, if we say static, oh sorry, static int a2 is equal to 10, a2 is equal to a2 plus a1, I believe it will refuse because A1 might be null. To use it, we need to learn on using conditions. So let's take a look on this condition. The next lecture we will talk in more details about conditions, but for now let's take in an exception. Can I parse it like int? Yeah, I can parse it. So maybe I don't need to take a condition. A1 is equal to 30 and A2 should be 40. But if this thing is null, this will crash because this one is null. So did you get it? So if it has a value, it will work because 10 plus 30 is 40, and this one, as we said, cast it mean treat it if it was an integer, not a nullable integer. But as I said, we're going to take a quick look on the condition. If A1 has value, this is a way to check the condition. Has value function, oh, it's a property, will return true if it has a value. Whoops. Oh my god. This is a way to say if A1 has a value, then do this operation. So if we run it, it will give it 40. If A doesn't have a value, it becomes 10. As I said, nullable are really useful for databases because databases can be 0 or null. And this is a big problem when you deal with a code and database. In conditions, actually, it will check if it is true and it works, so we don't need to make the equality and it will do the same result. That's it. I believe that's it. Let's take a look on everything in the notes. Oh, we didn't check the math. We have something called a math class, and in the math class, it's a static class that lives in the system. It has several math operations, including power, absolute value, the trigonometric functions, and maximum and minimum. So let's try one like power. And let's make double D1 because in power we deal only with double. 10. D2 is 2. And let's make it 10.2. So D1, D2. And this is a function. We can print it here. And we can say here D1, D2. Oh, I forgot to write static. So let's give it a try. And we got 104, which is 10.2 to the power 2. And you can use other functions just like math, like the absolute value of D1. And if we give it negative, whoops, sorry, I used the hotkey and it wasn't working yesterday, but now it's working. Sometimes, I don't know what to say. So the absolute value here, the one is -10, but it will print 10 because the absolute value, and I forgot to change this message. So there you go. We talk a lot on yeah, I didn't make integers in here because this is example, very bad example. We took a look on how to declare a variable. Let's make a fast review. Static integer I1, static long L1, which is the same byte b1, static float f1, static double d1, static decimal capital D, static byte or boolean, static character or char, static string. We'll learn about casting, like float, oh sorry, I1 is equal to integer, f1. We learn about parsing, f1 is equal to float parse string, like 10.55. I didn't focus on static value and variables. These are called variables. These letters, the names, these called static or Vix values, or constants. There's a way to give them a name, a constant, and you can take a look on them. We learn on several math operations and logical operations. Oh, we didn't learn about the bitwise. So here I1, this is math, this is bitwise operations can be used with values too. So if we have an integer and we say for example 10 or 1 will make it 11. I didn't teach that, and I should spend more time. Actually we have like 4 minutes. We can have more than 1 hour. And you have an and you have an XOR, similar to the booleans logical operation, but this is called bitwise operation. So this is an XOR and an OR, the same. What does it mean is, let's make it at the end in here. If you have a number like each integer number like 15 will turn into the binary number, which is four ones. And if you don't know about the binaries, I'm sorry, I'm not going to spend time. You can learn about the binary numbers and somewhere else. The first one equal to 2 to the power, let's go from the left, 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0, which mean 8 plus 4 plus 2 plus 1. So the first digit in our decimal line or in the binary language represent 1, 2, 4, 18. So if we get the binary number of 1011, it will be equal to 13. So this is 13. So if we make a byte-wise operation, for example 1111, and it with 0100, which in this case is 15, and it with 4, it will be equal to 13. Why? Oh, and it will be, sorry, XOR it. because 1 XOR with 0 is 1. Let's make AND example first. If we make an AND, it will be equal to 4, because anything you AND it with 0 is 0. So we took only the 4. If we take another number like 1 0 0 1 and it with, let's say, 0 1 1 0, and let's make it 0. This is 9 and it, oh sorry, OR it. I want to make an OR example. With 4 is equal to 13, because it will equal to 1101, which is equal to 13. So let's test this theory. 15 and it with 4. And this is equal to 15 and it with 4. Let's print 3 lines. As we say, the procedural languages work from the top to the down, from the main. So it will make this one, then this one, then this one. Of course, it will declare these values first as well, till it reaches. So it will print this line, then this line. And we said 9 by 4, or it by 4. And actually, I want to make the third example, which is XOR as well. Let's make it in here. So let's make it again. So 15 XOR it with 4 will make it equal to 1011, which is equal to 11, and this one equal to 0100. Hopefully, I'm sorry that I'm explaining things in fast, but this is the a reminder, not a teaching or a lecture on that. If you learn about the binary numbers, this is a reminder how to make the bitwise operations. So let's test the result. So 4 11 13, and there you go. If you want to learn more about the binary numbers, you can search it in your time. And I just trying to teach you how to become a better programmer. I cannot teach you everything, but I can show you the syntax, show you the things, and tell you you can go from here and learn more. And if we achieve to that level, that's more than enough for me. So let's return to our so we just done this. Give me a second, organizing my stuff. You can have a break for 5 minutes. You can pause and return. But for me, we need to finish the thing. So we want to show you a feature in the .NET today, and which is called the search. When you click on Control F, you can search for things. So if I say let's search for B1, you will see not only all the B1s in here, you'll see the small cases too, and you can say, hey, I want to match the whole word or case sensitive, so it will only show you B1. And the best thing about it, it doesn't only show you one by one, it highlight the rest, and it will highlight the rest in the bar in here. So if you see the green, the brown marks in here, it show you where these search results are. So this is really useful when you have files with thousands of lines. Not only that, you can highlight, for example, this one, and it will show you and highlight the rest. Because we never used it, it will highlight nothing. But let's highlight this one. it will automatically highlight everything, but it won't show the brown marks. The brown marks only shown when you search. When we click Control F, then you will see their position. Very useful indeed. So this is what the brown mark means. So this is the feature of today. Homework. Unfortunately, I didn't make the big surprising homework. Sorry about that. But no worries, we will get better ones when we learn more. If you're familiar with the declaration and assignment, how to declare the variables and how to use them, then you can skip this homework. But if you never code before, don't raise your nose and start working. Start working now. Apply what you learn. Don't say, oh, this is easy. Then you say, oh, I read that book and saw that tutorial and I didn't learn anything. And I want better tutorials. If you don't start working and if you don't do the homeworks, you will never learn. Because you will never experience what you read, what you watched. And how the heck do you think you will improve? Even in the simple homework, you will do some mistakes and you will learn from them. So I want you to make a program where you can take the user input and convert it to int, float, and double. We already saw, I don't want to give you a sheet, but we already saw that console, let's go to the program, read line. This actually take a string from the user. This return a value. So we can say int a is equal to, but this is a string. How do you convert a string from an integer? Well, hopefully you learned that from this class. So this is a hint up. And you can read the rest. You can pause and read the rest. Today I would like to show you a very useful website called .NET Pearls. So whenever you search for an info, let me get this one. For example, let's search for C# arrays. Keep your eye on .NET Pearl. If you don't get it, we can access it directly. Oh, come on. It's usually on the top, but maybe not today. Okay, let's access it directly. .NET Pearls. So this website supports several languages and give you several things. For example, strings. I prefer MSDNA, but I know MSDN, not MSDNA. It's a little bit complicated, a little bit hard to access the info you want, and it have tons and tons and tons of pages between guides and documentation and different languages, and it's sometimes hard to travel on that web page or that website. So sometimes you want something more simple to read. So the best thing about .NET.Pero, it gives you a very simple introduction. What the heck is this? It gives you some stuff that related to it. Then it gives you a very simple example for it. Then it gives you several examples. Each example, it will give you the easiest. Oh, weird. There's no examples about these things. Sorry about that. It usually, as I said. Let's go to the arrays, for example. What did I click on? Usually when you search for Google, it shows you results for .NET Pearls. But I wasn't lucky with the array for some reason. So it gives you an introduction, as I said. It gives you a very simple example. Then it gives you more complex examples. And it keeps giving you useful things and more complex in the order. So the easiest to the most complex thing. Very useful website, and it shows you even tips how to use in a better way. It gives you comparison for the performance between other things that related to the things you're searching for. Very remarkable website, I'm telling you. So let's try again. C# dictionary. MSDN, Stack Overflow, dictionary. Maybe the website is not as popular as it used to be. I don't know. To be honest, it used to be the third or the fourth result. I don't know why it's not that popular. Yeah, if I write dictionary.net perils, it gives you .net perils. But you can access the whole list from there. And it supports several languages. So that's what I wanted to add for today. Thank you for watching. This is the second lesson. Hopefully you learned something. And if there's any question in the chat. Oh yes, no one watching. Hopefully when I do it in a live code TV, people will be watching. At that time we can answer the questions in here. But nevertheless, thank you for watching and see you next time.